Move that over there, yeah. Oh, hey, my name's Adrian Acosta, and today I'm gonna talk about effects of stress on health. Let's get into it. We've all had butterflies in our stomach before, right? Your heart is fluttering before a big test on AP Bio. Well, that's something called stress at work. It could just be a short-term bodily effect, or it could be a long-term effect that's detrimental to your body if it continues. Just kidding. Well, not also. Today, I'm going to talk to you about how stress doesn't just impact our mood, it plays a major role in our physical health, influencing everything from our immune system to our heart. We'll look at what stress really comes down to from these 4 biology units: genetics, cell signaling, protein synthesis, and enzymes. Shall we? Well, genetics. Safe to say we all like this unit. Raise your hand if you did. 1, 2, 3, 4, 5, 6, 7, 8. Okay. First, we will talk about the role genetics play on our stress. Genetics play the role of influencing both how we experience stress and how our body responds to it. Let's get into it. When we humans are stressed, we have something called the HPA system that controls our stress response. Boom, right there. You see the graphic. But what even is that? HPA, or the hypothalamic pituitary adrenal. I tried to say that multiple times. I didn't know how. Sorry. Which is a handful to say. Yeah, that says it in the script. It's a complex set of influences in the brain that regulates many body processes, including digestion, immune responses, mood, and emotions. Another gene involved in this is the COMT gene. The COMT gene, or cathelical-O-methyltransferase, is a genetically predisposed gene, which means that you have it when you're born. Pop out, I got it. COMT affects how dopamine, a neurotransmitter, is broken down in the brain. Those with certain versions of the COMT gene might experience heightened stress responses in certain situations. Lastly, stress can affect the cardiovascular system a lot, sometimes too much in fact. This graphic shows how many different things affect the heart, like stroke. Now, with all that wrapped up, we're on to... Hey, now, cell signaling is one of my least favorite units, to say the least. But it's a very important process in our bodies. Cell signaling plays a critical role in how the body detects and responds to stress, acting as the communication system that coordinates hormonal and psychological reactions, not responses, throughout the body. Wow, that's pretty cool, you might say. But how does that tie into stress, you may ask? Well, I got it for you. Well, there's something called neurotransmitter signaling, which is basically when stress gets high, it triggers signaling through neurotransmitters, like adrenaline, see red, which affect heart rate, blood pressure, and alertness. But there is always something off with your body. It's not all fine and dandy. There's also something cell signaling does that is very grave. When stress gets extremely high, it becomes chronic. Chronic stress overwhelms the signaling pathways, making them overactive or unbalanced, in which long-term high levels of cortisol can impair immune function, promote inflammation, and increase the risk of heart disease. Also, it can even affect brain function in areas like the brain, which is involved in memory and mood. Finally, last part. We all know there are cell signaling pathways all over the body. Yes, but now we're on to the immune system part of the body, where stress gets out of control. It can cause really horrible things, like altering the signaling of cytokines, which are small proteins involved in immune responses. Also, under chronic stress, there may be an increase in inflammatory cytokines, which can cause damage in tissues and even contribute to diseases like cardiovascular conditions, autoimmune disorders, and even cancer. Finally over with cell signaling. We're on to Hey, everyone say, hey, protein synthesis. Hey, protein synthesis. Anyways, protein synthesis is the process your body uses to create proteins, which are essential for things like building muscles, like me, fighting infections, and repairing cells. But when you're under stress, especially for a long time, this process can change your body in many different ways. One major stress hormone, cortisol, can actually slow down protein synthesis in some part of the body, like muscles. This happens because your body is trying to save energy and make do with the stress. So, it focuses less on building muscle. My muscles don't do that. Just making sure. And more on muscle survival. Over time, this can lead to muscle loss and slower healing of the muscle. Blech.
Yes, we got a new outfit change. Still talking about the same thing. However, not all effects are harmful. In response to stress, your cells can also increase the production of certain protective proteins, like heat shock proteins. We all know those, right? The job is folding and unfolding of proteins, as well as in the assembly and disassembly of protein complexes. These proteins help keep other proteins from becoming damaged or clumping together when the body is under physical or chemical stress, like during a fever or exercise. So, in this way, protein synthesis actually helps your cells survive tough or grave conditions. Also, through protein synthesis, stress can affect the brain as well. Under normal conditions, protein synthesis in the brain helps us form new memories and adapt to new situations. But when stress becomes chronic, high levels of stress hormones like cortisol can actually interfere with this process. The result? The brain may produce fewer proteins needed for memory and learning, which can make it harder to focus, remember things, or even manage emotions. On the other hand, during short-term stress, some protein production in the brain increases to help us stay alert and process information. A little stress might sharpen the brain temporarily, but long-term stress can reduce protein synthesis and damage the parts of the brain that help us think clearly and remember. In short, stress affects protein synthesis in good and bad ways. It can shut down normal buildings and repair them when stress lasts too long. But it can also trigger the production of special proteins that protect the body in emergencies. Wait, finally, it's done. We're on the last topic. We're on it. Well, finally, we're here. Our last topic, enzymes. Our best buddies, our pals, like Philip would say. Enzymes are special proteins that speed up chemical reactions in the body. And they're really important when it comes to how we deal with stress. During stress, the body needs to react quickly, and enzymes help make that happen. For example, certain enzymes help produce stress hormones like adrenaline and cortisol, which get us ready to face a challenge and get us ready to see red. These hormones speed up our heart rate, raise blood sugar levels, and give us a burst of energy when we need it. And enzymes work mysteriously behind all the scenes when this happens, but it's not all fine and dandy. When stress lasts too long, enzymes' activities can become unbalanced. Some enzymes might stay active for too long, which can lead to problems like inflammation or oxidative stress, which is where harmful molecules build up in the cells and cause damage. This has been linked to diseases like heart problems, depression, and even age-related age-related issues. Enzymes also help with recovery. After stress, other enzymes break down the stress hormones and help the body return to normal. If those enzymes don't work properly, it's because of genetics, diet, or the constant stress the body can. But with constant stress, the body can struggle to calm down, which just keeps this stress cycle going. So, enzymes are essential for both starting and stopping the body's stress response. These keep things running smoothly, but if they're thrown off, stress can have a much bigger effect on your health. I think enzymes are a little bit like Marcus Rashford. We all just love him. Well. Here we are. It's the end. Kind of getting teared up. Never mind that. So, to wrap it up, stress affects our health in many different ways. It starts with genetics, which determine how we react to stress. It continues through cell signaling, protein synthesis, and enzymes, which all play crucial roles in how our body responds. Chronic stress can disrupt all of these systems, leading to serious health problems. Managing stress is essential to keeping your body where it needs to be. That is all for me. See you.